everyone, welcome back to the channel. Today we are going to solve this question called Kuroni and the impossible calculation on the Codeforces. So let us take a look at this question. So question states that to become the king of Codeforces, Kuroni has to solve the following problem. He is given n numbers, means he has given array of n numbers, and he has to find this cyclic multiplication where I goes from 1 to n minus 1 and j is bigger than I and j goes from 2 to n and mod of ai minus aj. So as a result can be very big, they are saying to output it modulo n. So this is just the definition of the cyclic product, and let us take a look at some example test cases. So in first test case, n is equal to 2, m is equal to 10, and the numbers are 8 and 5. M is equal to 10, numbers are 8 comma 5. So here only one pair is possible, mod of 8 minus 5, which is equal to 3, and 3 and 3 modulo 10 is simply 3. So in this case our answer should be 3. So it is correct. Let us take a look at the second example test case. So 3, 12, 1, 4, 5. N is equal to 3, m is equal to 12, and elements were 1, 4 and 5. So in this case this is one pair, so mod of 1 minus 4 into mod of 1 minus 4 into mod of 4 minus 5 into this is one pair and this is one pair, so mod of 1 minus 5, which will be equal to this 3 into 1 into 4, 12, and 12 modulo 12 modulo m, which is 0. So in this test case answer should be 0. So it is, answer is 0. So here in third test case 37149, seven 1 4 9. Similarly, like previous test case, this is one pair, this is one pair, and this is one pair. So mod of 1 minus 4 into mod of 4 minus 9 into mod of 1 minus 9, which is equal to 3 into 5 into 8. So which will be equal to 120, and 120 modulo 7 is 1. So in this test case answer should be 1. Okay, sorry for the disturbance. So in this third test case answer should be 1. And so basically if we think, our first intuition is that there is no other way than brute forcing the solution, right? So we have to access every element of the array, subtract it from its element whatever its pair is, and then multiply all the values and then take mod m. Okay, this is the way to go at the first sight. But when, see, this is the clever observation in this question. See, take a look at this m, take a look at its constraints. So m is going from 1 to 1000. Okay, so think, if suppose if what is the worst case, suppose m is 1000. Okay, m is 1000, and suppose if n is 1001. So if we take n is 1001, or generally speaking, if we take n is greater than m, then what happens? So we know that percentage m, any number percentage n, suppose number percentage m will give the values from 0 1 2 3 so on up to m minus 1. Okay, and take a look at this. Our product is mod of a1 minus a2 into mod of a1 minus a3 dot mod of a1 minus a4 so on up to mod of a1 minus an, then mod of a2 minus a3 dot mod of a2 minus a4 so on up to mod of a2 minus an. This is mod of a2 minus an, and so on it goes down till here. Okay, till mod of an minus 1 minus an whole mod. So what we can see is that when n is greater than m, suppose this whole thing, we have to take mod of it, right? Mod with respect to m, mod with respect to m. So we know that from the properties of mod, a1 dot a2 mod m, whole mod m can be written as a1 mod m into a2 mod m whole mod m. Okay, this is the property of modulus. So we can take this m inside to all of these moduluses. Okay, so it basically becomes like this: mod m minus a2 mod m, means every bracket which is in the form ai minus aj will now become mod of ai mod m minus aj mod m. So when n is greater than m, every value, suppose n can be written as then m plus k, suppose m plus k, where k is greater than 0. Okay, so m plus k is greater than m, and now these m values from those n values will get mapped. Suppose one value gets mapped to 1, second gets mapped to 2, third gets mapped to 3, and fourth to third, and so on up to mth value gets mapped to m minus 1. So but the remaining k values, see, the one value k is greater than 0, suppose take k is 1 for simplicity, then that one value which this element has will again map to one of these values. Okay, then what are we getting is that ai mod m and aj mod m will become the same and render whole this whole product to 0. Okay, so this is the trick to observe here. So whenever n is greater than m, our answer will be 0. This is the one of the best applications I have seen of the pigeonhole principle. Okay, so answer will be 0, and as m is less than or equal to 1000, if n is less than or equal to 1000, then only answer will exist in the sense it will be greater than 0. Okay, so now if I write O of n square solution, then it can pass within the time limit, right? Because n square will be 10 to the power of 6 in the worst case, which is still less than 10 to the power of 8, some typical machines operations per second. Okay, so it can pass uh, because of this constraint of m, that m is less than or equal to 1000. So that was the observation to be made in this question. So let us head to the code. So code is simple enough to understand and to realize as well. So this is the completion of input, taking input. If n is greater than m, then answer is 0. We have discussed it. And then continue for that test case. Then initialize answer as 1 and starting, then brute forcing basically. This all you know, it is easy brute force. So finally outputting the answer. So that is it, and it nicely passes the time limit. So hope you enjoyed the video and the solution. Thank you for watching the video. Like this video, stay subscribed to the channel. It was nice to see you on the board. Stay tuned.